Good afternoon today. As we discussed earlier, today we are going to discuss heat practical. So according to our practical list, the first practical to be discussed is practical number 25. Okay, so that is regarding the determination of specific heat capacity of solid material or solid substance using the mixture method of mixtures. Okay. Okay. Before starting to discuss about the practical, I need some time to discuss with you about physics practicals. Okay. So first of all, you have to understand about practicals. Actually, a practical, actually there is a specific concept relevant to practical. Therefore, first you have to understand that specific concept. In this case, there is a concept. So when you are doing a practical, the first thing you have to understand is the concept. Okay. What is the concept behind the practical? That thing is the utmost important thing to be understood. Okay. Otherwise, if you cannot understand that concept, then actually you cannot understand about the practical. Therefore, the most important thing is understand the practical, understanding the concept of the practical. Once you understood the concept, then you can apply that knowledge to the practical. Okay, that's mean that the procedure of practical is built based on the concept. Therefore, every precautions that we are going to use during the practical is based on that concept. Therefore, if you are asked to find some solution, then definitely that question is based on that concept. Therefore, the most important thing is understand the basic concept. Then the second thing is you have to correlate all the questions, or all the questions means all the given questions, so all the given questions to that concept. That means if you ask any question in the exam or in your term test, then you can find the answers using that concept. Again, මුලින්ම අපි concept එක understand කරගන්න ඕනි. ඔතන අහන හැම question එකම පුතේ අපි link කරගන්න ඕනේ අර concept එක. මම කියලා දෙන්න කොහොමද ඒක link කරගන්නේ කියලා. එක අමාරු නෑ, හරිම ලේසි. හැබැයි ඒක පොඩි අර මේ ප්‍රශ්න එකක් තියෙනවා. ඒක පොඩ්ඩක් අල්ල ගන්න ඕනේ. හරිද? ඒක පොඩ්ඩක් අල්ල ගන්න ඕනේ. එහෙම නැත්නම් අර මේක අර අපි කියන වගේ කටපාඩම් කරන්න පුළුවන් දෙයක් නෙවෙයි. Practical දෙයක් කියලා කියන්නේ කටපාඩම් කරන්න පුළුවන් දෙයක් නෙවෙයි. So you have to understand that one very well. Otherwise, you cannot do the answers. මේකේ තියෙන හොඳම දේ තමයි if you know all the things about practicals, then definitely you can get the full marks. අර essay question එකක් වගේ නෙවෙයි. You can get the full marks very easily if you understood the practical. අන්න ඒක තමයි මෙතන තියෙන වැදගත්ම දේ. මොකද practicals කියන දේ අපිට හරි මට දැන් මේක පොඩ්ඩක් කියන්න. දැන් අපි physics කරන දැන් අයියලක් කරන නිසා so how many marks you will get for the practicals in your A-level exam? A-level exam එකේදී ඔයගොල්ලෝ කොච්චර මාර්ක් එකක් ගන්නවද practical එක for your final paper? Final paper එකෙන් කොච්චර මාර්ක් එකක් practicals වලට එනවා? Give me an answer. ආසාවෙන් දෙන්න. බොල දරුවෝ මම මේ ෆිසික්ස් ක්ලාස් එකේ නේද උගන්වන්නේ කොමර්ස් එකක් එහෙම නෙවෙයි. ආ ප්‍රැක්ටිකල්ස් වලට අපි කොහොම ෆයිනල් පේපර් එකේ ලකුණු කීයක් ඔයගොල්ලන්ට හම්බ වෙනවද? ටෝටල් මාක් එකේ. මං අහන්නේ එච්චර. MCQ වලට කීයක් හම්බ වෙනවද? ටෝටල් මාක් එකේ. ටෝටල් මාක් එකෙන් MCQ වලට ෆයිනල් පේපර් එකේ කීයක් හම්බ වෙනවද? හ්ම්? ආව එහෙම නේද ඔයගොල්ලන්ට? What about others? How many marks you will get for the MCQ questions in your final physics paper? For your final physics paper? Hmm? How many marks? Final paper? අන්තිම පේපරේ ලකුණු කීයක් තියෙනවද MCQ? ලකුණු කීයක් තියෙනවද structure? ලකුණු කීයක් තියෙනවද SS? මං අහන්නේ ඒක. The final paper එකෙන් out of 100 නේ ඔයගොල්ලන්ට හම්බ වෙනවනේ. So out of 100, how many marks you will get for the MCQ? How many marks may you will get for the essay? Hmm? How many marks for the structured essay? Hmm? Okay. Okay. So out of 100, you will get 50 marks. You will get 50 marks for MCQs. MCQs. Okay. Then you will get 20 marks for structured essay. Then you will get 30 marks. 30 marks for essay questions. This is the structure of physics paper. This is the structure of physics paper. For the final marks, you will get 50 out of 100. 50 out of 100 for MCQs, 20 out of 100 for structured essay, 30 out of 100 for essays. Okay. But normally, for the MCQ paper, you will get 100 marks. Then it will be converted into 50. For the essay paper, you will get another 100 marks. Then it will be converted into 50. This is essay paper. Okay. So normally it's not the essay paper, second paper. Okay, second paper. Essay second paper. This is for the first paper, this is for the second paper. Normally, second paper consists of two parts. One is a structured essay, other one is essay. For a structured essay, you will get 40 marks. An essay, you will get 60 marks. Okay. Then, altogether it is 100 marks. Then it will be converted into 50. Okay. Finally, for the structured essay, you will have 20 marks out of 100. For essay, you will have 30 marks out of 100. Therefore, if any student can score more marks for MCQs and structured, definitely he will get a better pass. Okay. essay එකට බර දාන්න එපා කියනවා නෙවෙයි. නමුත් අපි structured essay එක MCQ එකයි කර දානවා කියලා කියන්නේ එතන පුතේ ඇත්තටම මේ පාස් එකක් තියෙනවා. හරිද? එතනම මේ පාස් එකක් තියෙනවා. අපි total mark ගන්න බෑ. ඉතින් මේ දෙක කර දාන එක මේකෙන් භාගයක් ගන්න බැරි මිනිස්සෙක් නෙවෙයිනේ. හරිද? ඒක නිසා ඒක කොහොමද ගොඩ යනවා. හැබැයි මෙන්න මේ දෙක නම් අපි අනිවාර්යෙන් ටාගට් කරලා කරන්න ඕන දෙයක්. ඒ නිසා සාමාන්‍යයෙන් මම ගොඩක් ටාගට් කරන තැන් දෙකක් තමයි මේ ලොකු කුට්ටිය මොකද ඒ කුට්ටිය කඩාගත්තොත් අනිවාර්යෙන් ඕනම වෙක්ටර් බොහොම ලේසියෙන් ලොකු විස්තරයක් ගන්න පුළුවන්. හරිද? ඕනම වෙක්ටර් විස්තරයක් ගන්න පුළුවන්. මොකද මේ දෙකට ට්‍රේනින් කරන ළමයෙක් අනිවාර්යෙන් මේක කොහොමද කරගන්නේ? මේක අනිවාර්යෙන් කරගන්නේ. හරිද? ඒක නිසා මේක මම ටාගට් කරන්නේ නැහැ කියලා නෙවෙයි. නමුත් මේ දෙකට මම වැඩිපුර වේට් එකක් දෙනවා හේතුව ඒතර තියෙන අර ගොඩ වැඩි මාක්ස් ගන්න වැඩි. හරි. Okay. Then structure එක මතක නැහැ මේ පේපර් එකේ. හරි. අපි එනම් ප්‍රැක්ටිකල් එක පටන් ගමු. Okay. Shall we start practical? So this is practical number 25. Practical number 25. I have sent you the practical books. Practical book එක තියෙන කට්ටිය මට පොඩ්ඩක් තම්බයක් දාන්න. If you have the practical book, please give me a thumb. As a hard copy, as a hard copy. One. Only one student. Yeah. You should have a practical book, okay? Our bookshops වල තියෙනවා පුතේ, bookshops වල තියෙනවා. You can buy that one practical book. So you should have that practical book. That is the methodology or method statement for the practicals. Therefore, you should have that one. That is a book published by the government. Therefore, you should have that book, okay? So please buy that one. Practical books. හරි. නැත්නම් ඉතින් මම මේක print out කරන්න පුළුවන්. print out කරනකොට මම හිතන්නේ ඊට වඩා ලාභයට hard copy ගන්න පුළුවන්. හරි. ඒක නිසා ඒක ගන්න සාමාන්‍යයෙන් bookshops වල තියෙනවා. හරි. හරි. Practical number 25. So what is the name of practical number 25? Determination of specific heat capacity. Of a solid substance determination of specific heat capacity of a solid substance by the method of mixtures. Method of mixture. Method of mixtures. මේක තමයි අපේ topic එක. එතකොට practical number 25 එක. So determination of specific heat capacity of a solid substance by the method of mixtures. Okay. 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 In this case, we are going to measure or going to determine the C value or specific heat capacity of a solid substance. Solid substance. Solid means it is a solid one. Okay. Determination of specific heat capacity of a solid substance by the method of mixtures. Please write the topic. The practical number 25. Practical number 25. ඒක that depend on you පුතේ මොකද if you can maintain a separate book it will be much better. It will be much better for practicals because all the practicals will be there. Okay. So if you can use a separate book for practical, it will be much better. Or definitely, I will send a structured tude for every practicals as I send you today. So you have to take print out of that tude. Then you have to fill that one. Okay. I think maintaining a separate book will be much better. Okay, much better. But you have to separately file that tudes. Okay. Bible okay. Shall I erase? Okay, everyone, please look at the board. Now I'm going to discuss or I'm going to explain about the practical. Please listen to this very carefully because this is very important. Okay, you have to listen to this very carefully. Suppose there is a water container. Water container. So if I heat up some solid material, suppose this is a metal. If I take a metal ball and heat it up to a certain temperature, suppose I'm going to heat it up to 70 Celsius or something. Then I'm going to place or I'm going to put this metal ball into the water container. So if I put that metal ball into that container, then what will happen? Tell me, what will be your observations? Suppose the water container, initially the water container was at the room temperature and the metal ball was at 70 Celsius temperature. And I have put metal ball into that container. Then what will happen? What will be your observation? Okay. Another one. Water heats up. Water heats up. Good. Very good. Complete answer. The temperature of metal ball. You can observe the temperature of metal ball decreases and the temperature of water increases. Okay. Then finally both come to a common or equal temperature or they will come to the thermal equilibrium condition. Thermal equilibrium condition. All right. Then tell me. So what is the reason? So what is the reason for decreasing the temperature of metal ball and increasing the temperature of water? What is the concept behind that? Yes, heat transfer. Okay, heat transfer from higher temperature to the low temperature. Okay. According to our previous discussion, the transferred heat or the heat loss by the higher temperature material is equal to the heat gain by the lower temperature material. No. So according to that concept, so if there is a no heat loss to the surrounding, okay. So if there is no heat loss, listen to this very carefully. If there is no heat loss to the surrounding, heat released or heat lost by this metal ball should be equal to the heat gain by whom? By whom? Heat gain. Very good. Very good. Water plus the calorimeter. Water plus the calorimeter. All this content. I'll touch on a calorimeter. Give it. So this container. Okay. Therefore, this is the concept. This is the concept that we are going to use to determine the C value of a solid material. Okay. As we put the metal ball into a water container, so we call this method as a mixed method. Method of mixtures. Method of mixtures. Mix කරනවා වගේ එකක් නෙවෙයි ඒක නිසා අපි මේක method of mixtures කියලා කියනවා. So the concept behind that is the heat transferring method. So the heat lost by a higher temperature material is equal to the heat gained by the lower temperature material. Okay. If there is no heat loss to the surrounding. So the concept behind this method of practical is this. So suppose you know the C value of this container. You know the C value of this container, and you know the C value and the mass of this container. Suppose you know the mass and the C value of the water. C value of the water. Then you can calculate, or then you can determine the C value of metal. Wait a minute, okay. Okay, what we are discussing about this one. Suppose you know these values. You know the mass of the water and you know the C value of the water. If you know the C value of the container and if you know the mass of the container, then you have to determine or you have to measure the temperature difference, no? Initial temperature and the maximum temperature gained by the water. Okay. If you determine, so if you measure those temperatures, then you can get the theta value. So, other thing, you have to measure the weight of this one, weight of the metal ball. So if you know these data, then you can write an equation, no? The heat loss or heat released by this metal ball can be determined using MC theta. I can apply MC theta for the metal ball. And the heat gain by the system can be determined using that same equation, no? MC theta. MC theta for water plus MC theta for the container. So the heat lost by the metal ball, heat lost by the metal ball should be equal to the heat gained by the water plus container. Water plus the container. So if you know the relevant information, that means NW, CW, MC, CC, sorry, MC, CC, then MM, and if you measure the temperature difference also, that means you know all the factors related to this equation, no? So if you know those factors, then you can calculate the C value of metal. Did you get my point? Did you get the concept, basic concept? Everyone, I need your responses. So this is the basic concept. This one should be understood very clearly. This one should understand very clearly. Everyone? All right. Okay. But the thing is, listen to this very carefully. This is the most important thing. This relationship or this equation is valid only if there is this relationship is valid only if there is what? If there is no liquid, no. No heat loss. Very good. If there is no heat loss. This equation is valid only if there is no heat loss. Okay. That is the most important part of this concept. Okay. බලන්න මේ concept එක. මේ concept එකෙන් කියවෙන්නේ මෙන්න මේක heat loss by the metal ball is equal to the heat gained by the water and the container. Okay, but this is valid only if there is no heat loss. Therefore, when you are doing the practical, you have to take whatever precautions to validate this equation. Otherwise, doing this practical is meaningless. Then, අපි අනිවාර්යෙන් මේ equation එක validate වෙන විදිහට අය practical එක කරන්න ඕනේ. Otherwise, that is meaningless. Therefore, you have to take the whatever precautions to maintain the validation of this equation. තේරුණාද? Did you get my point? මෙන්න මේක මේක ගන්න තියෙන දේ. ඒක නිසා හොඳට මතක තියාගන්න ප්‍රැක්ටිකල් එකක් කරනකොට concept එක බලා ගන්න ඕනි. හොඳට තේරුම් ගන්න. ප්‍රැක්ටිකල් එකක් කරනකොට concept එක. ඒක ඕගොල්ලෝ හොඳට තේරුම් ගන්න ඕනි. ඒ concept එක validate වෙන conditions ටික තේරුම් ගන්න ඕන. හරිද? ඒ validate වෙන condition ටික practical එකේදී ඔයා maintain කරන්න ඕන. ඒක තමයි practical එකේදී අපි questions අහන තැන් ටික. ඇයි උඹ මේක කරේ? ඇයි උඹ මේක කරේ? මේක නැතුව මේක කරොත් මොකද වෙන්නේ? ඈ? අන්න ඒව තමයි අහන්නේ. ඒක නිසා ඒ ඔක්කොම බේස් වෙන්නේ පුතේ මෙන්න මෙතන. ඒ වැලිඩේට් වෙන කන්ඩිෂන් එක මේන්ටේන් කිරීම. ඒක හොඳට මතක තියාගන්න ප්‍රැක්ටිකල් එකේ අහන හැම ප්‍රශ්නයක්ම බේස් වෙන්නේ අන්තිමට අතන. හැම ප්‍රශ්නෙම කියන්නේ හැම ක්වෙස්චන් එකම කියන්නේ 99 ක්වෙස්චන්ම බේස් වෙන්නේ අතනට ඕන තව ක්වෙස්චන් එකක් දැක් ඕන පුංචි කැල්කියුලේෂන් එකක් තියෙන්න පුළුවන්. තමක් හරි අපිට දැක් ගන්න පුළුවන්. නමුත් අපි ගත්තොත් එහෙම more than 95 questions are based to that on that මේකස්. මොකද්ද? concept එක basic concept එක valid වෙන මේ එයාගේ validation එක මේ base factors ටික ඒ factors ටික අපි practical එකේදී කොහොමද maintain කරන්නේ? හරි practical එක තුල අපි ඒක maintain කරන විදිහ. ඔන්න ඔකයි තේරුම් ගන්න. ඕක තේරුම් ගත්තොත් ඔන්න ඔතනින්ම තමයි ඕගොල්ලන්ට questions අහන්නේ. ඒක හොඳට තේරුම් ගන්න. ඒ නිසා ප්‍රැක්ටිකල් එකේ ඔයා බෝලේ උස්සනවද බෝලේ එහෙන් තියනවද මෙහෙන් තියනවද හැම දෙයක්ම ඩිසයිඩ් කරන්න ඕනි මෙන්න මේ වැලිඩේෂන් එකට කිසිදු හානියක් නොවන විදිහට. So you have to do whatever things maintaining this validation. Without maintaining validation, you cannot do anything. Okay, that is the most important thing during the practical. ඒක හොඳට මතක තියාගන්න. ඒක තමයි ප්‍රැක්ටිකල් එක ඕගොල්ලන්ට තේරුම් ගන්න වැදගත්ම දේ. Okay. Did you get my point up to this? Tell me. If you have any question, please let me know. Because now I'm going to explain the real practical. So up to now, do you have any questions up to now? Do you have any question up to? No. Okay. Now, no, it is not possible to do heat loss without any heat loss, but we can minimize the heat loss. Therefore, you have to take whatever precaution to minimize the heat loss. Okay. Otherwise, we cannot do this practical. Okay. Okay. There. Okay. As I explained you earlier, we are going to heat up some metal balls. Then we are going to put these metal balls into a water container which is at the room temperature or something below that. Okay, I will explain that one. Okay. Then what we are going to do is we are going to measure the maximum temperature attained by this system. Okay. So to do that, we will use a stirrer and thermometer. We will use a stirrer and a thermometer. Tell me, so what is the purpose of a stirrer? This one is called as stirrer. Stirrer. Month again. Stirrer. Stirrer. So what is the purpose of this stirrer? Purpose of stirrer? No. Okay, once you put the metal balls, suppose there is only one metal ball. If I put the metal ball into the water, The water near to the metal ball, the water near to the metal ball heats up relatively high degree. But when you go little bit far away from the metal ball, the temperature will not be equal to the temperature around that area. Right? The temperature around the metal ball or closer to metal ball will be relatively high. But if we go away from the metal ball, the temperature of the water around this area will be relatively low than to this area. Therefore, the temperature of the water will not be a constant value. So, if it is not a constant value, we cannot measure the heat gain of the water and as well as the calorimeter. We cannot measure the actual heat gain because there's no constant temperature difference. How can we measure? It is very hard. Therefore, we cannot maintain the initial assumption. We cannot maintain the initial assumption because we cannot measure the actual temperature gain correctly. Okay, that word is very important. We cannot measure the actual heat gain of the water correctly. Right. That means the temperature reading near to the thermometer will not be the actual temperature gain. May not be the actual temperature gain. Therefore, we have to maintain a constant temperature throughout the water. Therefore, you have to distribute the temperature throughout the water. That's why you are going to use a stir. Okay? When you are, once you put the metal ball into the water, you have to stir. You have to stir. When you are stirring, the temperature will be distributed evenly throughout the water or throughout the system. Therefore, if you measure the temperature from here or from here, the temperature will be same. Did you get my point? So what is the purpose of this stir? Did you get my point? මේක හොද්දට ඔලුවට දාගන්න මේක හොද්දට ඔලුවට දාගන්න හරි මොකද හොඳට තේරුම් ගන්න පුතේ ඕගොල්ලෝ structured essay question එකට answer දෙනකොට straight forward short answer එකක් දෙන්න ඕන. You cannot write a long essay. You cannot write that one. If you are asked a question in structured essay paper, you have to give a straightforward short answer. Therefore, you have to have very good understanding about the article. Otherwise, you cannot write the correct answer. And, so, what is the purpose of stir? Tell me, what is the purpose of stir? Using a short and correct terms. Tell me, what is the purpose of this stir? Stir එකක purpose එක මොකක්ද? ටක් ගාලා කියන්න within using very straightforward words. කියන්න. හම්දා? ශාක්‍ය? No. No. No, Rashini, you are correct. Exactly. We are not going to distribute heat here. Heat එක distribute කරන්න නෙමෙයි යන්නේ. We are going to. What is the purpose of this term? Hmm? Hmm? Distribute the temperature evenly throughout the water. Temperature. You are not going to distribute heat. You are not going to distribute it. බලන්න words වල තියෙන වැදගත්කම මම ඇහුවේ නැත්තම් ඔයගොල්ලෝ ගොඩක් වැරදි. හරිද? අන්න එක තේරුම් ගන්න. ඕගොල්ලෝ heat කියෝ ගමන් no marks. No marks. Marks දෙන්නේ marks දෙන්න word temperature. You are going to use a stir to evenly distribute heat throughout the water. That is the purpose of stir. හරිද? ඒ words setting ඉරි ගහනවා. ඒ words setting ඉරි ගන්න මම ඔය හැම question එකක්ම අහලා තියෙනවා මම අර මේකේ tute එකේ. So if you give the answer for tute, definitely all the questions will be there. Okay. I have another one. I will discuss that thing later. But other than that one, all the questions are there. All right. Did you get my point? මම එකින් එක පුතේ මම හිමින් සැලේ කරන්නේ. මොකද මේක හරියටම තේරුම් ගන්න ඕනේ ෆිසික්ස් ප්‍රැක්ටිකල් එකක් කියන්නේ මොකද්ද කියලා. හරි. නැත්තම් නිකන් ආවට කියලා කරලා තේරුම් ගන්න මේක. හරි. Did you get my point? Everyone, I need your responses. Did you get my point? Did you get how to answer for a structured essay question? Very good. පාර අහන questions වලට දැන් අර දුන්නා වගේ answers දෙන්න හැමෝම. මට එතකොට ඕගොල්ලන්ගේ මේ answers බලා ගන්න පුළුවන්. හරිද? ඒ නිසා මේ හැමෝම participate වෙන්න. Very good. So now we are going to use use heated metal balls, and then we are going to put them into a water container. Then we will stir the water and get the highest temperature, the highest or maximum temperature of the system. Okay, that word is very, very important. You have to get the maximum temperature reading. If you write the word, the final temperature, it will be no marks. So what is the difference between final temperature and the maximum temperature? Final temperature and maximum temperature අතර වෙනස මොකක්ද? අනේ කියන්නේ බැරි වෙලාවත් ඔයගොල්ලෝ කිව්වොත් එම මේ ළමයි මෙතන කරන ලොකුම වැරද්දක් මේක. ළමයි අතින් මිස්ටේක් වෙන ලොකුම තැනක් මේක. මොකද්ද? ටග් ගාලා කියනවා අර මෙටල් බෝල්ස් ටික දැම්මා, ස්ට්‍රයි කරා, ෆයිනල් ටෙම්පරේචර් රීඩින් එක ගත්තා. That is wrong. That is wrong. If you say final temperature, definitely wrong. That should be the maximum temperature, not the final temperature. So what is the difference between maximum and final temperatures? Everyone, you have to participate in this discussion. I need answers from everyone. So what is the difference between the final temperature and the maximum temperature? Why I am saying like this? මම කියනවා final temperature නෙවෙයි හරි word එක maximum temperature කියලා. ඇයි? The wording is much more important in structured essay questions. Okay. මේ word මේක තනි කරව word fight එකක් තියෙන්නේ. හරි word එක දුන්නේ නැද්ද ඉවරයි. ඇයි මේක maximum temperature කියලා කියන්නේ? ඇයි ඔක final temperature කියලා කියන්න බැරි? ඒක කියන්න කලින් ඕගොල්ලෝ හොඳට දැනගන්න ඕනේ මොකද්ද මෙතන වෙන්නේ කියලා. Yes, very good. Very good, Prasad. That is the reason. Okay. Not up to the room temperature. It will be decreases with time. Okay. Okay. Then, okay. Look at this one. Everyone, please look at the board. Everyone. Okay. Once you put metal balls into the water container, what will happen? The heat from the metal ball will be transferred to the water container. Then the temperature of metal ball decreases and the temperature of water and container increases. No? Then what will happen? Initially the metal ball is something like this level and the water container something like this level. Okay? Once they are mixed, what will happen? The temperature of metal ball goes down. The temperature of temperature of water goes up. Goes down, goes up, goes down, goes up. Then they come to a thermal equilibrium. So that is the point. That is the maximum temperature of the water, no? That is the maximum temperature of the water system. After this temperature level, then what will happen? Then this heat will be lost to the environment. The make a environment make heat loss in the pool. Once the heat loss is happen to the surrounding, then what will happen? The temperature of the entire system will go down. අපි හිතන්නකො මේක 70 තිබ්බා මේක 100 තිබ්බා මේක 30 තිබ්බා කියලා හිතන්නකො මේ ටික දැම්මට පස්සේ මෙටල් බෝල් ටිකට මෙටල් බෝල් ටික දැම්මට පස්සේ හිතන්න මේක 50 සෙල්සියස් වෙන්න පුළුවන් 50 සෙල්සියස් වෙන්න පුළුවන් 50 සෙල්සියස් වෙලා මෙයා මෙහෙමම ඉන්නේ නැහැ අපි චුට්ට වෙලාවක් මේක තිබ්බොත් එහෙම මොකද වෙන්නේ ටික වෙලාවකින් මාගේ ටෙම්පරේචර් එක බහින්න ටික වෙලාවකින් ටෙම්පරේචර් බහින්න as example හිතන්නකෝ ඔයගොල්ලෝ තේ හදන්න ඕනේ කියලා. තේ හදන්න ඕනේ වුණාම ඔයා හීටර් ජග් එක අරන් මේ වොට් එකක් රත් කරලා මොකද කරන්නේ? දානවා මේ ජාර් එකට. කෝප් එකට. කෝප් එක දැම්මම පස්සේ මොකද වෙන්නේ? කප් එක දැම්මම පස්සේ ටික වෙලාවකින් මොකද වෙන්නේ? එන දිවෙනවා. ඔයා ටික වෙලාවක් මේකට ගියම මොකද වෙන්නේ? අනිවාර්යයෙන් හීට් ලොස් වෙලා සරවුන්ඩින් එකට මේක දිවෙනවා. So I don't know the final point. If I take much longer time, definitely the final temperature value will not be the maximum value. That is the problem. So we cannot say final temperature because we do not know the final point. We do not know the final point. එක්කෙනෙක් නැවතුත් පැයකට විතර පස්සේ තව එක්කෙනෙක් නැවතුත් පැය භාගයකට පස්සේ තව එක්කෙනෙක් නැවතුත් දවසකට විතර පස්සේ මොකද කරන්න පුළුවන් heat loss එක බෑ. So that is wrong. So you have to get the maximum temperature of the water. Look at this one again. Initially the metal ball, the temperature of the metal ball was at this level. The temperature of the water system was at this level. Once they are mixed, the temperature of the metal ball goes down, the temperature of water goes up, goes down, goes up, goes down, goes up, then comes to a point. So this is the point, this is the maximum temperature point of the water. Water everything had an So if I keep much longer time, then what will happen? The temperature of the entire system will be decrease. So that is the reason we are not going to use the word final temperature. We are going to use the maximum temperature of the water system. Okay. Therefore, you are going to measure the maximum temperature of the water system after mixing the water ball, sorry, no, not metal ball and the water. And metal balls we water mix කරාට පස්සේ ස්ටාර්ට් කරලා the maximum temperature. You have to get the maximum temperature. Did you get my point? Turn on. Everyone, I need your responses. Therefore, this is very important thing. This is very important thing. Okay. So you have to mention that word. So what is the practical? Now, what is the practical? Practical is you have to mix heated metal balls with a water container, and you have to stir well and get the maximum temperature of the system. So that is the practical. So that is the practical. බොහොම simple practical එකක් තියෙනවා. මොකද්ද? water container එකක් ගත්තා, heat up කරපු metal balls ටිකක් එක දැම්මා. දාලා stir කරා the maximum temperature එක. එතනින් read maximum temperature එකක් ගත්තා. ඔච්චරයි. හැබැයි වැදගත්ම දේ මේක කරන්නේ කොහොමද? and so final output එක ඔක උනාට ඔක කරන්න යන පාත් එකක් තියෙනවනේ. අන්නේ OCD එකයි ඔයගොල්ලෝ ඉගෙන ගන්න ඕනේ. and okay. So you have to mention that important part. Okay? You have to memorize those important part. Or they don't know me keep a word that path. For the in the bag or the rally where I have. ඒකමං මම ඔයගොල්ලන්ට MCQ කරනකොට පුතේ මෙමොරයිස් කරගන්න ටග් ගාලා මයින්ඩ් එක යූස් කරලා ගන්න විදියක් මම කියා දුන්නා ගන්න විදි. හැබැයි ඒකයි මේකයි ටෝටල් ඩිෆරන්ස් එක දැන් ඔයාලා තේරෙනවා. මේකට ආන්සර්ස් දෙන විදිය වෙනස්. මම ඒක දැන් මේ කියා දුන්නා. තනි කරම ආන්සර්ස් දෙන විදිය වෙනස්. හරි. ඔකේ පුතා. ඉස්සරහ. හරි ඉස්සරහ. හරි. Okay. Now, so what is the concept of this practical today? Can anyone tell me the concept of the practical? The concept of practical. The concept of practical. Okay, the concept of practical is heat lost by the metal balls is equal to the heat gain by normally, yes. Normally, we are going to use a calorimeter as the container. Calorimeter දැකලා තියෙනවද? Have you seen that one? Calorimeter. I think when you are in oral stage, I think you might seen that one. Huh? Calorimeter. දැකලා තියෙනවද? No. ෆොටෝ එකක් පෙන්නන්න. කැලෝමීටර් කියලා කියන පුතේ නිකන් අර මේ normally normal calorimeter කරගන්න අර පිත්තල පාට තියෙන පොඩි කප් එකක ෂේප් එකක් තියෙන එකක්. හරි. No, ඒක ඉන්සුලේටඩ් කන්ටේනර් එකක් නෙවෙයි පුතේ කැලෝරීමීටර් කියන්නේ. අපිට ඉන්සුලේෂන් කරගන්න පුළුවන්. ඉන්සුලේටඩ් කැලෝරීමීටර්ස් තියනවා වෙනවා. It is they are not insulated ones, but there are insulated calorimeters, but this is a normal calorimeter. We have to insulate that one because there are a lot of purposes of calorimeters. Therefore, insulation of calorimeter is required for this kind of particles. Okay. Use of star. Use of star again, star use to evenly distribute the temperature throughout the water. So that is the purpose of star. Okay. That is the use of star. To evenly distribute the temperature throughout the water. The correct word is temperature. Don't use heat. Heat එක distribute කරන්න නෙවෙයි ඒක use වෙන්නේ temperature distribute කරන්න. හරි. අතර මොකද වෙන්නේ? දැන් මේ බෝල් ටික මෙතන දැම්මට පස්සේ මෙතන වටේ තියන්නේ පුතේ මේ heat වෙච්චි මේවා මොනවද? water particles. දැන් water metal ball එක මෙතන දැම්මට පස්සේ මේ වටේ water particles heat up වෙනවා. අපි ස්ටයර් කරාට පස්සේ මොකද වෙන්නේ? ස්ටයර් කරනකොට මේ water particle හතර වටේ යනවා. එතකොට ටෙම්පරේචර් වැඩි වෙච්ච water particles හතර වටේ යනවා. දැන් එතකොට තමයි අලුතෙන් particles මෙතනට එනවා. අලුතෙන් particles එතනට ඇවිල්ලා ඒගොල්ලෝ තව විදිහට heat up වෙනවා. ස්ටයර් දිගින් දිගටම ස්ටයර් කරනකොට අර heat up වෙච්ච particles යනවා throughout the water. Therefore, the purpose of this stir is to distribute temperature evenly throughout the water. Temperature. That is the correct word. Don't use heat. Don't use the word heat. Okay. In this practical, we are going to use a calorimeter as the container and stir. Normally, the stir and the calorimeter are made up of same material. Same material. If not, you should know the C value, or that means specific heat capacity of calorimeter as well as the heat stir. If they are made up of same material, then one C value is enough. Okay. So the heat is absorbed by, or heat is gained by water. Heat gained by water plus calorimeter plus stir. Calorimeter and stir are actual metals. Therefore, definitely they will get some significant value of heat. Okay. कुछ प्रश्न है? हम මොකද්ද කිව්වේ? බලන්න. මෙයාගෙන් loss වෙන heat එක කවුද absorb කරේ? or කවුද gain කරේ? Water plus calorimeter plus stir කියලා කිව්වේ. Okay. water විතරක් නෙවෙයි calorimeter තියෙනවා stir එකක් තියෙනවා. stir එක. පුංචි ප්‍රශ්නයක් ඕගොල්ලන්ගේ පුංචි ඔළුවට ආවේ නැද්ද? ටිකිරි මොලේට ටිකිරි ප්‍රශ්නයක් ආවේ නැද්ද? No. It is almost immersing calorimeter in water. I will draw the correct figure. Until then, you're going to see that one. But normally, almost thermometer. Why I did not write thermometer? Because it is inside the water throughout the particle. Hmm? Isn't it absorb any heat, any heat? Huh? Like heat का absorb करने अंदर thermometer. Hmm? Huh? Thermometer का absorb करने अंदर ये मत thermometer का मैंने thermometer का heat का absorb करने it is negligible because if I use a good thermometer, it should not absorb temperature heat from the system. If it is absorbed, then the temperature reading will be incorrect. Thermometer එක heat එක absorb කරොත් correct temperature reading එක කිය දෙන්නේ නැහැ. Right? එයාත් heat එක absorb කරලා එතකොට අතන තියෙන temperature reading එක නෙමෙයි හරියට එන්නේ. Therefore, if I use an accurate thermometer, the heat absorbed by a thermometer will be negligible. Okay, so normally, as this is a practical, we are going to use an accurate thermometer. If it is an accurate thermometer, definitely the heat absorption should be negligible. And after thermometer making thermometer tapi tinggal temperature බලුවා කියලා thermometer එක රත් වෙන අපිට දැනලා තියෙනවා. නෑ. Normally we use glass as the outer material. Normally glass is a very poor conductor. Therefore, the heat absorption can be considered as zero. And චූට්ටක් දෙනවා ඇති චූට්ටක් loss වෙනවා ඇති නමුත් අපිට ඒක negligible කියලා හිතන්න පුළුවන්. Did you get my point? So remember who is the donor and who is the absorber. The metal ball will be lost. So actually, the metal ball give heat, and that heat is absorbed or heat is gained by the water, calorimeter, and the stud. Okay, so that is the concept of this practical. So, as I told you earlier, to validate this concept, there should not be any heat loss to the surrounding. Therefore, to validate this equation, we have to maintain a condition like that without any heat loss to the surrounding. Okay. Therefore, if there is no heat loss to the surrounding, heat loss by the metal ball is equal to the heat gained by the water plus calorimeter plus stud. So that is the concept. Then this concept should be converted into a mathematical equation. As you know, and as I told you earlier, heat loss or heat gain can be determined or can be calculated using MC theta equation. Q equal MC theta equation. So to apply Q equal MC theta equation, you should know the value of M, value of P, value of C, and value of theta. Okay, those are the three things you should know. Therefore, during this practical, you should measure those things. Normally, the C value is a given data. It is a given data. Other two, that means mass and the heat, mass and the temperature difference should be measured during this practical. Therefore, you should organize this practical to measure the mass values and the temperature difference. Okay. අන්න ඒ practical එකක් අපි decide කරන්න. හරිද? මොකද්ද concept එක? මොකද්ද given value? මොකද්ද measured කරන්න ඕනේ values? අන්න decide කරන්න. So අන්න measured කරන්න ඕනේ values ටික during the practical අපි measure කරන්න ඕනේ. measure කරන්න ඕනේ practical එකේ validation එකට හානියක් වෙන්නේ නැති වෙන විදිහට. හරි. Okay. Then tell me, what are the readings? So what are the data or information you need to calculate or calculate the C value of this metal balls? What are data? The first thing is the mass, mass of the calorimeter. Calorimeter plus star. Calorimeter plus star. If they are made up of same material, otherwise you have to measure them separately. If they are made up of same material, you can measure the mass of the calorimeter plus star at once. Same model. Then you can pour some water into the calorimeter, then measure the mass of the calorimeter plus star plus water. That is M2. M2. That is M2. මට බෝල වතුර මේ water ගත්තොත් එහෙම පුතේ water වල mass එක නිකන් බලන්න බෑනේ water වල mass එක බලන්න නම් අනිවාර්යයෙන් water මොකක් හරි container එකකට දාන්න ඕනේ. හරිද? ඒක නිසා initially මම මේ අර empty මේ calorimeter එකේ මම weight එක ගත්තා ඊට පස්සේ water දාලා weight එක ගන්නවා. එතකොට මේ weight දෙකේ difference එක මට කියන්න පුළුවන් water වල weight එක කීයද කියලා. දැන් මම M2 M1 කියලා කියන්නේ water වල weight එක. water වල weight එක. Okay. Then mass of the metal balls. Normally, we are going to use lead shots. Lead shots. Lead shots. Lead shots කියලා කියන්නේ මොකද්ද? අර ඊයන් ගුලි තියෙන ඊයන් වලින් හදපු ගුලි. lead කියලා කියන්නේ ඊයන් කියන එකනේ. ඊයන් වලින් හදපු අර මේ ස්පේස් වගේ පුංචි අර ගුලි වලට අපි කියනවා මේ lead shots කියලා. ඊයන් මූනිස්සන් කියලා කියනවා අපි ඒකට. lead shots. Those are the mass or weight readings. Then we have to measure the initial temperature. Initial temperature of water. Water means water plus calorimeter plus system. The initial temperature of water. Then the initial temperature of the metal balls. The initial temperature of the lead shots. Then you have to measure the the maximum temperature after the mixing. Maximum, not the final. Maximum temperature after mixing. Okay. Those are the things you are going to measure during the practical. Practical later. Okay, measure did you get my point, everyone? මේ ටික මෙෂර් කරලා අපි කරන්න ඕනේ පුතේ දැන් මේක මොකද කරන්නේ අපි මේ ටික කරමු මොකද්ද මේ ටික මොනවද ඉලෙක්ට්‍රොඩ්ස් ටික අපි හීට් අප් කරලා දාන්න ඕනේ කැල්කුලේටර් එකේ ඕකේ හරි okay now once I measure the initial measurements then what should I do I have to prepare a water container. That means I have to pour some water into the calorimeter. Actually, during the measurement, I already prepared that one. Then I should start heating up the metal balls or lead shots. Now, how to heat them up? Because it should have fixed temperature, no? Once you heat them up, their temperature should be fixed. Suppose you are going to put them into a container and you are going to heat them up. If you are heat them like this, you cannot have a fixed temperature because suppose you need to stop this heating at 70 Celsius degree. Okay. You are going to put some temperature heat, the thermometer heat. Actually, if it is near to 70 Celsius temperature, can we stop the heating? Can we stop the heating? No, we can. Okay. ඒ කියන්නේ 70 වෙනකන් අපි මේක තියන් හිටියට 70 වල පස්සේ අන්න 70 වුණා ඒක නිසා මම මේ හීට් දෙන්නේ නැහැ කියලා හීට් එක නැති වෙනවද? නෑ. මේ කැන්ඩල් එක අර තියෙනකන් ඔක හීට් අප් වෙනවා. හරි. ඒක නිසා මේ විදිහට මේක අපි හීට් කරන්න බෑ. මොකද අපිට ෆික්ස් පොයින්ට් එකක් ගන්න බෑ. ෆික්ස් පොයින්ට් එකක් ගන්න බෑ. හරි. එහෙනම් මොකද කරන්නේ? ෆික්ස් පොයින්ට් එකක් ගන්න බෑ. Then what should I do? Tell me, what should I do? කොහොමද fixed point එකක් අරගන්නේ? Yes. Then how to get a fixed point? If I use water, how to get a fixed point? Hmm. අපි water එක use කරොත් කොහොමද fixed point එකක් ගන්න පුළුවන්? නෑ ඒක හොඳයි. ආන්සර් එක හොඳයි. මට ඒ වුණා විශ්වාස කරන්න. No. If we allow to reduce the temperature, still we cannot stop the temperature at that point. Can we? Can we hold the temperature at 70? No, we cannot. We cannot. Then you have to have a fixed temperature. Fixed temperature. You know where we can have a fixed temperature. You know that thing. Where can we have a fixed temperature? Fixed temperature का तीन तरह किया. Fixed temperature तीन तरह. Oh, 70 can be. Yeah, if there is a phase change. Yeah, melting point, melting, no boiling point. Yes, if there is a phase change, definitely there is the temperature is a fixed point, fixed one. Very good, very good. Your answer is very good. Therefore, I'm using water. I'm going to use water. I'm going to use water to heat them up. I know if I use the boiling point of water, the temperature of boiling point is equal to Celsius 100, no? 100 Celsius. Therefore, if I keep metal balls with 100 Celsius water, definitely I can have a thermal equilibrium condition because the boiling point or 100 Celsius degree point will be fixed until all the water is evaporated. අන්තිම water බිඳුවත් evaporate වෙනකන් අර Celsius 100 හැමෝම තියෙන වෙනසක් වෙන්නේ නැහැ. ඒක නිසා මට අන්න ඒ temperature ගන්න පුළුවන් තේ fixed point එකක් හදා ගන්න. කොහොමද මම මේක කරන්නේ? ඒක තමයි වැඩිපුරම තේරුම් ගන්න ඕනේ වැඩි. Okay. In this case, I will use this kind of arrangement. Okay. I'm going to use this kind of arrangement. Normally we call it as boiling tube. Boiling tube. In this boiling tube, there's a arrangement like this. This is a tube. This is a double tube, actually. This is the outer tube. Inside that tube, there's another tube here. This tube can be rotated. Okay. One side of that tube is connected to this level, and other side will be a shorter one. It will be a short one, and there's an open. There's an open here. And then the first you have to keep the inner tube like this. Then you have to put metal balls into the tube. And then if you rotate this inner tube, what will happen? This open will come to this location. මේ open එක මෙතනට එනවා. මේ open එක මෙතනට ආපු ගමන් මොකද වෙන්නේ? මේ බෝල් ටික බොස් ගාලා වැටෙනවා. හරි. ඔන්න ඔකයි. හරි. ඒ නිසා හොඳට මතක තියාගන්න මේ inner tube එකේ තියෙන විදිහ. හරි. Then there is a water container here. There's a water container. Then I use a Bunsen burner to heat this up. Then what will happen? What will happen here is once I heat the water of the boiling tube up to 100 Celsius, then what will happen? Up to 100 Celsius. When it comes to the 100 Celsius, it will be at the same temperature until the end of the entire water phase. The entire water phase is move in the 100 Celsius. Therefore, definitely, this metal ball will be in thermal equilibrium with this system. අනිවාර්යයෙන්ම system එකත් එක්ක මේක thermal equilibrium එකට පත් වෙනවා. මොකද මේ 100 celsius තියෙනවා පුතේ ගොඩක් වෙලා. හරිද? ඒක නිසා මේ 100 celsius මේ lead shots ටික අරගන්න. එතකොට lead shots වල temperature එක fixed temperature එකක් හම්බ වෙනවා 100 celsius කියලා. 100 celsius එක fixed temperature එකක් හම්බ වෙනවා. That is most important part of this practical. Okay. How to give a fixed temperature. How to give a fixed temperature for lead shots. කොහොමද lead shot වලට fixed temperature එකක් දෙන්නේ? Give me the answers. How to give a fixed temperature for lead shots? lead shots වල අපි කෙලින්ම CSS දෙන්නේ. Tell me. මේක තේරුණාද වෙච්ච දේ? Everyone, please tell me. Did you get my point? So my explanations up to this level. Okay. So tell me the answer for my question. Answer for my question. What is my question? How to give a fixed temperature for lectures? Lectures so like be fixed temperature there. मैं 70 celsius में example है कि मैं 70 celsius में 100 celsius दे नहीं है ये example है कि 70 celsius में नवत्तर back in we cannot stop 70 celsius. So that is an example. That is an example. Therefore, you have to choose a fixed temperature. 70 Celsius is not a fixed temperature. If you want to use fixed temperature, if you want to use 70 Celsius as a fixed temperature, definitely you have to select a material or liquid with a melting point at 70 Celsius. No? No, that is not the answer. Mata answer record, hurry answer record. Suppose this is a exam question. What is the question? How to get a fixed temperature for lead shots? Lead shots or fixed temperature gun. බලන්න මේ ආන්සර්ස් දෙන විදිය මාරෝ වටිනා ආන්සර්ස් දෙන විදිය මට හැමෝගෙම ආන්සර් එකක් ඕනේ මට දෙන්න පුතේ මට හැමෝම ආන්සර් එකක් දෙන්න වැරදුනට කමන්නේ හැමෝම ආන්සර් එකක් දෙන්න. There's only one answer here. Nanda, Christian, Yanusha, ඔකට්ටිය මාකි රසන් විරාජ් රශිනි ඔකට්ටිය කියන්නේ ආන්සර් කියන්නේ ඕනම ආන්සර් බලවලක්. My question එක මොකද්ද? මම කොහොමද lectures වලට fixed temperature දෙන්නේ? Lectures වලට fixed temperature මම දෙන්නේ කොහොමද? So that is the question. How do you give a fixed temperature for lectures? No, Irishika, you have to change your answers. Question. No, no. Risha, you're closer to the answer, but it is not a complete answer. There is not a complete answer. Amna, Janisha? Oh, කට්ටිය. Hmm? Come on. How do you ensure the lead shot gets under Celsius temperature? How do you ensure? Tell me that thing. කොහොමද ඔයා ensure කරගන්නේ lead shots එක 100 celsius ගත්තා කියලා? So how to do the 100 celsius or fixed temperature for the shot? මොකද වෙන්නේ මෙතන? What did I do here? What did I do here? Oh, what did I do here? I keep lead shots in a thermal equilibrium. I keep lead shots in a thermal equilibrium with boiling water for certain time period. Then I can ensure the lead shot should have that temperature. All the lead shots should have that temperature. Okay? Because I keep that lead shots in a thermal equilibrium. And you can ensure that using the thermometer. Okay? Using the thermometer, you can ensure that thing. How to give the temperature? The answer for how to give the fixed temperature is keeping lead shots in a thermal equilibrium with boiling temperature for certain time period. Then definitely that is the method of giving 100 Celsius temperature to be for lead shots. Lead shot වලට අපි 100 Celsius දෙන්නේ එහෙමයි. මොකද කරන්නේ? lead shots ටිකයි boiling water දෙකල්ලෝ මම තියා ගන්නවා thermal equilibrium එකේ. thermal equilibrium එකේ තියා ගන්නකොට මම දන්නවා temperature එක equal වෙනවා. ඒක ensure කරගන්න පුළුවන් thermometer එකෙන් ensure කරගන්න පුළුවන් thermometer එක මම මෙතන use කරලා තියෙන නිසා මට ensure කරගන්න පුළුවන් මු හරි Celsius එක අපි ensure කරගන්න එකයි ensure කරගන්න එහෙමයි. එතකොට කොහොමද අපි දුන්නේ thermal equilibrium එක? ඒ කියන්නේ boiling water එකයි මේකයි thermal equilibrium එකට තියාගත්තා. හරි. Did you get my point? තේරුණාද? හොඳට මතක තියාගන්න එක දෙයක්. අපි temperature එකක් දෙන්න කොහොමද කියලා අහනකොට මොකක් temperature දෙනවා නම් අනිවාර්යෙන් දෙන්න පුතේ ඒ දෙන්න thermal equilibrium එකට ගේන්න ඕනේ. thermal equilibrium එකට ගේන්න ඕනේ. ඒ නිසා thermal equilibrium එකට ගේන්නද මේ අර temperature දෙන්න බෑ. හරි. Okay. So instead of using boiling tube, this is a boiling tube. And there are some features in boiling tube. I will discuss that thing later. So before that, instead of boiling tube, if I use a water bath, actually I can use a water bath. Water bath means suppose if I use another water container, and I put the metal ball here, and if I heat up this container up to the 100 Celsius, then I can give that same temperature for the metal ball. Actually, what is the temperature metal ball? If I use a water bath, normally we call it as water bath. If I use a water bath to give the temperature for lead shots, there might be a problem. Due to that problem, we cannot use this system. So what is the problem? What is the problem? Yeah. That is, that answer can be accepted. But the thing is, that is not the answer, means that make again. Correct answer again. You got second, third answer. So what is the first? The first reason, or the most important reason to avoid this kind of heating. Again, if I ask, suppose if I ask you, if I ask a question from you, please go to the basic concept. Please go for the basic concept, which we use during the practical. A concept එකට මේකෙන් හානියක් වෙනවද? ඒ concept එකේ validation එකට මේකෙන් හානියක් වෙනවද කියලා බලන්න. Okay. Everyone, please look at the board. If you are asked a question from a practical, the first thing you have to determine the concept. The concept and the validation of that concept. If there is a step, if there is a step, and from that step, there will be a violation of that validation. If there is a violation, definitely we should avoid that one. Whether there is a violation of the acceptable criteria or not. If I heat up these lead shots using a water bath, when you are taking them out, definitely there will be water outside the metal ball. No, definitely when there will be water, we cannot wipe them out. Can we wipe? No, we cannot wipe. Because when once you take them out, immediately you have to put them into the water container. Otherwise, there will be definitely heat loss, because we cannot assure the water, the lead shot. The lead shots at the 100 Celsius. So if we want to assume the lead shots are at 100 Celsius, definitely you have to, once you take them out, immediately you have to put them into this container. If you take much longer time, definitely there will be heat loss. The temperature of lead shots will be decreased. So you cannot wait. The problem is, if you take them out, definitely there will be water outside the metal board. So if you put them immediately into this calorimeter, the lead shots are not the only one. The lead shots are not the only one who gives the temperature, who gives the heat to this system, because they come up with water. That water was at 100 Celsius. The water was at 100 Celsius. Therefore, the lead shots come up with 100 Celsius water here. Therefore, the lead shots are not the only one who gives the heat to the system. That water, that 100 Celsius water also gives heat to the system. Therefore, definitely our assumption will be actually our assumption will not be valid. Will not be valid. According to our assumption, the metal balls are the only one who gives the heat to the system. Therefore, heat lost by the metal ball is equal to the heat gained by the calorimeter and the other system. So in this case, not only metal ball, but also there will be some water mass. But the thing is, we cannot measure that mass. We cannot measure that mass. That's a problem. And so definitely there will be a additional heat that cannot be determined. So we cannot use our assumption if I made this kind of mistake. තේරුණාද? හැමෝටම තේරුණාද? Did you get my point? If I use a water bath, if I use a water bath to heat metal balls, when I am taking them out, definitely there will be some water outside the metal ball. No? The temperature of that water mass is 100 Celsius. Therefore, if you put the metal ball into this container, definitely the metal ball as well as that water, will give the heat or will release the heat to this system. Therefore, the equation should be changed. The initial equation cannot be used. The equation should be changed. The heat lost by the metal ball plus heat lost by the water. But the thing is, the heat lost by the water cannot be measured because we cannot measure the mass of that water. We cannot measure the mass. ඒ කියන්නේ metal balls එක ඇලිලා එන වතුර වල mass එක අපිට ගන්න බෑනේ පුතේ. ඒ mass එක ගන්න බැරි නම් එතනින් එන heat එක මට ගන්න බෑ. එතනින් එන heat එක ගන්න බැරි නම් අපි මේ කරන්නේ ලොකු වැරද්දක්. අපි equation එක validate නැහැ. Did you get my point? Everyone, please let me know. තේරුණාද? Okay. Thank you. Therefore, we cannot use a water bath to heat this one. Okay. The other three. Can we use a plate or pallet? If we use a pallet or plate and keep the metal balls inside that pallet or plate, then you can heat. You can have a thermometer here. So if I use this kind of arrangement, can you accept that thing? Can you accept the thing? Yes, very good, Putha, very good. the temperature will not be controllable. That means we cannot hold the temperature. We cannot hold the temperature. Okay, we cannot hold the temperature. It is rising only, it is rising only. And it is rising only, therefore we cannot keep the temperature as a fixed value. And so therefore we cannot use this kind of temperature arrangement, this kind of heating arrangement, because we cannot control the final temperature, or we cannot control the temperature of the system. Other thing is, we cannot keep a thermometer like this. We cannot keep. If I keep a thermometer like this is the metal ball. Thermometer touches the outside of the metal ball or electrode. Therefore, it gives the reading, the temperature reading of the outside only. Okay, because it touches the outside. Suppose the temperature of the outside is 100 Celsius. So, although the temperature of the outside surface is equal to 100 Celsius, the inside temperature might be some lesser value. It might be some lesser value than the outside temperature. Okay. If you use this kind of dry system, definitely the outer surface temperature might be a higher value than inside temperature. Okay. මොකද inside එකට යන්න පුංචි time එකක් ඕන. ඒ time එක නැතුව අපි බැලුවොත් එහෙම අනිවාර්යෙන් මේක temperature මේක temperature අනිවාර්යෙන් difference. Therefore, the temperature of a ball or of a lead shot will not be a constant. The outer surface temperature might be higher than the inner temperature. Okay. Again, it will, if I use this kind of arrangement, definitely our assumption or our concept will not be validated. Okay. Did you get my point? හොඳයි. දැන් එහෙනම් පුතේ අපි කතා කරා කොහොමද ලෙඩ් ෂොට් එකක් හීට් අප් කරන්න කියලා. බලන්න මේ චූටි ප්‍රැක්ටිකල් එකක් වුණා කතා කරන්න තියෙන දේවල් ටික හරිද මාන දේවල් ටිකක් තියෙන කතා කරන්නේ. හරි. අව එකම දේ මේක එකක් හරියට කතා කරොත් ඊළඟ ඒවා කතා කරන්න ලොකු දේවල් නැහැ. එකක් හරියට කතා කරොත්. මොකද මේකව තමයි ඊළඟ දේවල් ඇප්ලයි වෙන්නේ. හරිද? ඒ දේ තියෙන්නේ. හරි. The next thing is this one, the calorimeter, the water plus calorimeter system. Okay, normally when we are taking water into this calorimeter as a standard, you have to fill this calorimeter up to this level, up to 1 centimeter below the top level. This is our thumb rule, up to 1 centimeter below the top level. So what is the reason for that one? What is the reason for that one? The reason is we cannot use much lesser water, and we cannot use this much of water. Both should be prohibited. Both are prohibited. Why? What is the reason? Why can't we use a lesser amount of water? Why can't we use? Tell me two reasons to reject this one. Tell me two reasons to reject this one. Why can't we use this kind of arrangement? Hey, everybody. බලන්න පුතේ මේවා තියෙන හිතන තියෙන දේවල් හිතන තියෙන දේවල් ආව තියෙනම ප්‍රැක්ටිකල් එකක් ගත්තා නිකන් ආවට කියලා කරන්න බෑ ප්‍රැක්ටිකල් එකක් මොකද මේක හේතුව මේකයි බලන්න if I put less shot here due to the insufficient water level definitely less shot will be contact with the surrounding air. Therefore, heat might be lost to the surrounding. Herman, may අපි insufficient water level එක use කරොත් මොකද වෙන්නේ? less shot ටික දැම්මම less shot ටික air එකට surrounding air එකට expose වෙනවා. It will be exposed to the surrounding. So due to this exposure, the heat will be lost to the surrounding. And the heat loss happening. That is one reason. Another reason to reject this one. Other reason is, according to our assumption, the entire system should have a common constant temperature value. Okay, if you put less shot here, after keeping some time, there might be the maximum temperature reading. That means the temperature of the entire system should be equal. But if I use this kind of arrangement, look at this one. If I use this kind of arrangement, this area is not with the contact, is not in the contact with water. මෙන්න මේ section එක බලන්න මේ section එක waterත් එක්ක contact වෙලා නැහැ කියන්නේ මෙයා මෙන්න මේ section එක අනිවාර්යෙන් water වල තියෙන temperature එකට මේ section එකේ ඉන්නේ නැහැ. So these sections will not be come to the temperature of water because they are not in a contact with water. Therefore, this might be a correct one because it is up to the maximum height. If it is up to the maximum height, definitely the water and the entire surface of calorimeter is in a contact. If they are in contact, definitely the temperature can be equally every phases. Yeah. Third, if I use this kind of arrangement, what can be evaporate? Because the water amount is much lesser. It is the amount of water is very much lesser. So if I put my large number of lead shot here, definitely it will come to the boiling point and evaporate. Okay, that might be a huge problem. And if they are evaporated, if the water is evaporated, definitely there will be heat loss. because the heat is gained by the water, and that water particle will be evaporated. So that water particle is not with the system. Now they are in the surrounding. Therefore, that heat will be lost to the surrounding. Will be lost to the surrounding. Therefore, if I use this kind of system, definitely that will be another problem. Now we can jump to this kind of system. Okay, so due to the disadvantages in this system, you can suppose theoretically this might be the system, because the entire water level, the entire system is covered by water. The entire system is covered by the water. Therefore, the temperature of water should be equal to the temperature of calorimeter. So why can't we use this kind of arrangement? I have may arrangement use करने Yes, water can spill out. If I put metal balls here, definitely water will be spilled out. If water will be spilled out, that means the mass of water will be changed. So you know the C value of water. It is relatively very high value. 4,200, it is relatively high value. So if there is a very small mass change here, according to Q equal MC theta, C is 4,200 m into 4,200. C also known. So as this value is a large value, if there is a very small mass loss, if there is a very small mass loss in water, the amount of heat loss will be much higher. Again, punchi mass change hekata when a heat change water wala C value එක වැඩි. ඒක නිසා චූටි mass change එකකට වෙන heat loss එක ගොඩක් වැඩි. හරි. ඒ නිසා අපිට මේක use කරන්න බෑ. මොකද මේක use කරපු ගමන් මෙයා spill out වෙනවා. spill out වෙච්ච ගමන් ලොකු heat loss එකක් වෙනවා. හේතුව මෙන්න මේක. මෙයාගේ මොකද්ද C value එක වැඩි ගොඩක්. හරි. Did you get my point? Okay, tell me, do you have any questions after this one? Do you have any questions after this? Do you have any questions after this? Metan time after question at the Okay, so now you know the concept and some very important points and how to heat the metal balls using a boiling tube. This is boiling tube. Then why cannot we use a water bath or this kind of arrangement, correct arrangement? Then the water level, the accepted water level during this practical, and what are the reasons for that? Okay, tell me, up to this level, do you have any question? Maybe got practical, have I? How you can make understand put one shot? Heat to the practice among it. Okay, very good. Okay. මම එහෙම වුණොත් අපි next week එකේ අපි ඊළඟ සෙම් එක කරමු. මොකද මම එහෙම කරන්න කිව්වේ ඊළඟට තියෙන්නේ අපේ most important part එක මේක කොහොමද pressures වලට පරිවර්තනය කරන්නේ සහ මේකින් එන pressures මොන වගේද වෙන්නේ ඊළඟට කොහොමද practical එක ඉවර කරන්නේ. precautions මොනවද? අන්න ඒක discuss කරන්න තියෙන්නේ. So I need the participation of all of you. හැමෝගෙම participation එකට තියෙන්න ඕනි. මම හිතනවා මේක රෙකෝඩින් බලන කට්ටිය එහෙම වුණොත් අනිවාර්යෙන් next week එකේ lesson එකට එන්න. මොකද next week එකේ අපි lesson එක කරලා structured papers share කරනවා. ඒ කියන්නේ exam එකට ආව structured papers share අපි කරනවා. හරිද? ඒ නිසා next week එක අනිවාර්යයෙන්ම exam papers ටිකක් අපි කරන time එකක් තියෙනවා. හරිද? හැබැයි next week එකේ අපිට එනවා මේකක් නේ. මේ කවද්ද next week එක කියලා කොහොමද ඉස්සරහට දෙවෙනි You have to go for school, no? School යන්න වෙනවද? third නේ. School ගිහලා ඉවරලා තමයි vacation එක එන්නේ. මේ හරි. හරි කවන්න. එහෙම වුණොත් එහෙම next week එකේ අපි පුළුවන් තරම් ඉක්මනින් ක්ලාස් එක පටන් ගන්න බලමු. 5:30 පුළුවන් නේද? 5:30 වගේ පුළුවන් නේද? Next week. No, we cannot wait much longer time, Puti. We cannot wait. Okay. So if you may actually if you may keep the heated metal balls inside water, definitely may finally the final temperature should be equal. But the thing is, if you keep much longer time, definitely there will be a heat loss. Therefore, you should finish or we should complete this practical as quick as possible. Okay. Therefore, you cannot wait until the water and the heat until the water and the metal ball come to the thermal equilibrium. You cannot wait. Okay. Again, therefore, you have to give a help to come then thermal equilibrium. Thermal equilibrium again now help කරන්න ඕනේ. ටක් ගන්න එක එහාම යකලා. හරි. පොඩ්ඩක් ගහනවා වගේ කරන්න නෑ. හරි. Okay. So we can complete today's class with this is our explanation. So actually I have explained some deeper actually I give some deep explanation here because this is the first practical of heat. Normally the most of precautionary methods will be applied for other practicals. Therefore, if we discuss this practical descriptively, then it will be much helpful for the practical. Unpractical කරනකොට අපිට මේ තරම් deep යන්න ඕනේ නැහැ. හේතුව අපි දැන් අපි දන්නවා concepts. අර concepts ටික අපි හරියට දැන් ඔලුව දාගන්න. හරිද? especially මේ water use කරන විදිහ ඊට පස්සේ කොහොමද අපි අර constant temperature එක තියාගන්න විදිය ඊළඟට heat loss එකට තියෙන precautions මොනවද ඒවා හැම එකටම common. හරිද? ඒ නිසා practical එක විතරයි ගොඩක් වෙලාවට වෙනස් වෙන්නේ. Precautions ගොඩක් වෙලාවට common. හරි. Alright. Okay. So we can continue to discuss that. Then not from next week, but after next week we can do some extra classes. Okay. Okay. So everyone, thank you and I want to say recording set करना
Thank you, sir. God bless you.
एक बता